Hi, Leo Drager here. I want to talk to you guys about buffer overflows and how you can, one, learn about the basic processes of buffer overflows, but I kind of want to take you past some of the theory and show you some of the hands-on to testing and evaluating buffer overflows. So basically what we're going to do is look at a stack-based buffer overflow that I've written in C programming. So I open up the document here, and I just want to kind of explain this to you, so that way you can follow along and try to reproduce this on your own. This is definitely going to be like a monkey see, monkey do type of lab. So give me 1 second here. I'm trying to resize uh, um, the text here. So let's do. It starts with it. Well, let's talk about the basics first. You basically have the first section here, and then the second section down here. So the first section is in main. Close the or start the parenthesis in argument C, comma, space, character, asterisk, argument value, and whatever that is, in parentheses, and then bracket. So if the argument that's copied is less than 2 characters, basically print a statement, you need a value, and then exit out. Otherwise, if we do, if it's greater than 2 characters, like 10 characters, for example, it's going to basically copy that and then basically print a statement. The value is, whatever, which is actually down listed down here. So we're basically supplying a value and then printing that value. And you can see that there's a string copy, the buffer overflow, and then the arguments from the previous value up here. All right, we've set the buffer here to 10 characters. And so what we're going to prove here is that when we're going through here, just because we choose something beyond 10 characters doesn't really realistically mean that, the program's going to crash or bad stuff's going to happen. In many cases, programs buffer overflow all the time and they work just fine. So it's only in certain instances where you get a lot of buffer overflow that the program actually crashes. And so when we compile this and execute it, we're going to go through a series of commands. And we're going to use the GDB, for example, and we're going to go through and we're going to look at the compiling this in GDB, and you can see actually how this works, and I'll show you some of the variables that you can use to actually see this run. Okay, so nonetheless, it's a very, very, very basic program. Clearly, these could be pages long, but that's okay. So let's go ahead and open up a terminal. And the first thing we're going to want to do here is basically compile this. And I've already got it compiled, but I'll show you the syntax anyway. So if you want to follow all along, you're more than welcome. So what I'm going to do is we'll just do a GCC, the name of our source code, which in this case mine is stack. Stack.c, and we're going to do this with the ggdb compiler switch. And what that does is that allows us to kind of set some of the breakpoints inside of the program as opposed to actually putting them in the source code, which is actually helpful. And then you can set your output file to whatever you want to call this. So since I already have this called, stack .c, you could do it, whatever output name you want, whatever you want to execute or refer to this file as. So stack.c is what I did before, but just to show that this works, I'm going to do, stack1. So if you get an error here, then you can basically see, start troubleshooting. So in this case, if you look at the print working directory, I'm not actually in the right directory. So let's go ahead and change directories to, in this case, I'm working in desktop. And let's just run the command again because that should be where the name of it is. And it compiles, but it gives us some information. In function main, warning, incompatible implicit declaration of built-in functions, string copy enabled by default. However, it is just a warning, so it should still be able to execute just fine. but nonetheless, you realistically be looking for error messages here. If you get an error message, then things went bad. So, for an example, if I take out my end bracket here in this piece here, you'll see that it basically will error out. Or if I put too many brackets in or something like that, file. Let's go ahead and save this as stack2. Okay, and then I'll show you basically what an error messages looks like. So in this case, same exact thing. Save this stack2, and let's call this stack2. Boom. There you go. Now we got the error message. Expected declaration or statement of value. Now, most of the time when you're compiling C code or writing C code, 99% of the time it's going to be a syntax error somewhere, an extra declaration, too many, too little. So go ahead and look at syntax and troubleshoot that first. Just because it doesn't work, don't freak out. It's all part of the learning experience. Think of it as like hide and go seek for errors. And that's the way you want to approach this. Don't get frustrated. Don't want to give up. Continue through, because this is very much a problem solving. All right, so I did it once without an error, just a couple warnings, and then I created an error just so you can see, what bad syntax looks like if you happen to do this wrong the first time by yourself. Anyway, all right. So next, let's go ahead and now that we've actually got this ran and we got it compiled, let's go into GDB, and you're going to want to run this basically like you would any other program. So I'm going to run stack, which is the name of my program, and you can see copyright information here at the top. This GDB was configured as i46 Linux. Read more symbols. Now, one thing to do here is to make things easier for your eyes and to illustrate basically to put this in easy syntax so you can actually read it like a human, is going to go ahead and set the disassembly flavor to Intel. And you basically do that by declaring set disassembly -f, and then you can tab your way through for flavor and set it to Intel. And it should come back, no problems right there. And then go ahead and you can type list. And list is a helpful command to know when using this, because it'll start showing you basically what your source code looks like. And you can use that, especially when we start getting into, breakpoints and deleting breakpoints and things like that. Because you can test this out by declaring this. Now, again, I want to back up right to what I did in the beginning. When I actually compiled this, I compiled this with the -ggdb switch. That allows me to set the breakpoints now that I'm actually inside this program, as opposed to having it in the compiled code. So we set the disability flavor, then we listed out the contents of the source code, which we can see here. But let's go ahead and run this. Now, to run this, we can do a Perl statement. And you can do this by basically typing run the program, $, bracket, or parentheses, Perl.execute, single tick, print a, which is the value that we want to print into the input or copy into our buffers, times 10, semicolon, single tick, and the parentheses, and see what it looks like. And you can see, starting the program, the location which we ran the program, $Perl, basically print a 10 times, and if you count those up, they should be equal to 10. And you can see that the program basically accepted that, and fine. Okay, great. So let's basically buffer overflow this. Okay, let's use the value of 11. You can see it ran just fine. Now, I'm not going to increment this by 1, so let's do 20. Let's see what happens if we put 20 A's in there. Okay, you can see the program still worked fine. If we do 25, we get a fault. Okay, and I'm just gonna auto program some values in here. So if I do like 50, start it from the beginning, yes, you can see I get a whole bunch of 50 A's in this point, and you can also see that it's actually stating the memory register here, and we're gonna come back to this in a second. But 414141, this is all A's, and you can actually prove that if you were to change it to, for example, B's. Start the program from the beginning, 41.41 or 4141 and 4242, A, B, if you want to get creative here. And this is, how you learn. This is how you learn this stuff. Start it from the beginning again. You can see that it's 4-3. Right? If I wanted to see what the value of, 10 is, start from the beginning. Boom, there you go. That's 30, 31, 30, 31, okay, or 1010. So we're going to go back to A's just for simplicity. Run it again. Okay, there it works. All right, so now what we're doing is we're basically supplying value to the executable. It's copying it to the buffers, and it's basically buffer overflowing. Now, there's not a convenient way to look at what's actually happening to your buffers at this time. So in order to do that, we basically have to look at the buffers. Okay, so let's do an x / 20xw, and let's look at the extended stack pointer. Okay, so basically simply doing asking it to print where it is in the stack. Now this is going to be helpful, and I can change this if I want to change from 20 to 40 or 400 or whatever I want. I can print as much or as little of the buffer as I want. 20 is fine, but basically we would be looking directly right in here, right in this section here, because you can see all the 4141 41 41 right all the way through here. Right. So if I change this, if I go back to, let's go back to print 500 A's to the buffer, start the program from the beginning, have it error out, and then go look at the buffers, and let's look at the first, let's keep it consistent, 500 characters. You can see that now my buffer is all 41414141. So I'm actually proving that the buffers do in fact get overwritten at the different memory locations as here on the left, right? So it's nothing but, overflowed buffers at this point. All right, and I hit enter a few times, and you can actually see where that ends, and then it picks up other values at the end of that, okay? And so what I'm proving here is that the buffers are in fact getting overflowed, okay? So let's go ahead and list some things out here. I want to show you guys a couple more things here before we wrap it up. I want to show you how to set breakpoints in here, right? So if we go back to our program, you can see that we've got, and you could do this with the list command earlier, but basically it's right in here. So if you want to look at this right before the the buffer gets copied, and check the buffers and check the stack pointers, and then let the buffer overflow happen, and then check the buffers again and kind of look at that just one line at a time, you can do that. Now, a couple of different ways you could do that. You could actually, count the lines down like this. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's like right around 9 and 10. Okay, is where we want to set breakpoints. Again, this is the value of actually compiling this with doing a -ggdb, okay, because I can set the breakpoint to 9, and it says breakpoint 1 set, and then breakpoint 10 set. I set another one. Right now, if I run the code, okay, it'll execute it, and I'm going to change this back to 10. It'll execute it, but it'll basically break right at the 9 and allow you to basically look. So it's ran the program, copied the 10 A's, and then braked here for me to see, and then I can look at the and I'm only going to look at the first 40 of the extended stack pointer. So if I look at that here, you can see basically the buffers look fine. I mean, I get all sorts of stuff in here. So, nothing really to see. And then if I change this again, let's go back to 500. Start from the beginning, yes. Okay, and then look at the values in here. And we'll just look at the first 40. If I look at the first breakpoint after but before the buffer overflow happens, I'm proving that the buffers look absolutely fine. Just a bunch of random stuff. I don't see any null operators. I don't see, your repeated values from the string that I copied, which is why I wanted to do like all A's or all 1 zeros, or just to make it completely obvious. Or null operator 0x90, just look at that pattern all the way through it. You want to make it obvious when you're learning this so you can actually distinguish what normal buffers look like versus complex buffers. And then you can go through and then actually see more what it looks like. If you want to delete the breakpoints and remove them completely, you can actually just put delete and delete all the breakpoints. Yes, no, that'll get those to go away, and then run the command again from the beginning, and then check your registers, and then boom, there you go. Buffers are now overflowed. So that is the absolute basics to doing a buffer overflow. Now we haven't looked at exactly how this gets exploited. What's being disclosed, what code is being arbitrarily executed, how is it crashing the system, what memory is it taking, what does task manager or top look like, right? So if I just give you an example here, if I'm going to look at top, what does that look like? And these are all things that you could look at in the grand scheme of things to really understand what your buffers are doing on your system. So that's a summary. Just to give you one summary real quick, we basically took some buffers, copied them, printed them. We compiled the program using the -ggdb. We ran the program gdb space dot / and then the name of your program. We set the disassembly flavor to Intel. We listed the code. We looked at the code. We ran a basic Perl statement to basically just supply input to the program. We looked at the different stack pointers. I showed you how to change the stack pointers with x / 20xw, or 500 if you want to look at the first 500, and things like that. So very, very basic, very, very easy way. Now that you've seen this, the key to actually making this make sense is to go ahead and reproduce this, make your own errors, and work through these and get through these on your own. And then you will start having a better understanding of how a buffer overflow works. And then, hey, at the end of the day, if you want to tell your friends and family, hey, I created a buffer overflow. Okay, then you can say you actually did it. But if you cannot do this, and you don't know how to do this, well, there are lots of, hackers out there that, do not know how to write a buffer overflow. And I've just clearly proven that it's not that hard. So I want you guys to practice. I want you guys to understand this. And, if you have any problems with the video, why don't you send me a link on the contact me section, and I'll answer any questions you have about buffer overflows. My name is Leo Dreger. Thanks for watching. Don't forget to check me out on Facebook, LinkedIn, YouTube, and Twitter. Also, by now you should be well familiar with the Cybrary IT website. Be sure that you are sharing, connecting, because that's how you move up in the application. Use it, learn from it, share it, and take it for all it's worth, because that's why it's here.